Welcome to this presentation. My name is Andrew Mallett, and today we're going to take a look at some of the file systems available in Linux and what they're used for. So there are an array: the riser file system, ext3, ext4, btrf, JFS, XFS. Just sounds like alphabet soup, really, doesn't it? Of course, we've got the etc fs tab file, and this is where we use the configurations to mount our file systems automatically when our system boots. So we can look at the fs tab file and also the mount options. ext3 is the default in SUSE SLES 11, but it's just an ext2 file system with a journal. We can check and get some debug information from the file system with dump2efs. We'll take a look at all of these commands and these file systems as we go through. An often overlooked file system is XFS from Silicon Graphics. It was developed in 1994 and is a 64-bit file system, so it was well ahead of its time, and is designed as a performance file system to be able to deal with very large files, but it will cope with small files as well. But it was specifically designed for their IRIX system and large 3D modeling systems. We can defrag the file system. Often people say you don't defrag, or there's no need to defrag a Linux file system. Well, of course, file systems can become fragmented, and there is a defrag command, XFS_FSR, to defrag the XFS file system. This is missing in other file systems. Also, another cool tool is the XFS_freeze, where we can essentially pause a file system. This might be useful where we're creating an LVM snapshot, so we can ensure, without bringing any software down, there are absolutely no writes in that moment that the snapshot is created. So we'll take a look at some of these file systems and hopefully give you an understanding of how they are used. So on my SUSE SLES 11 machine, and first of all we'll just type the command mount by itself to see which file systems are mounted. So we can see at the top SDA2 is mounted to the root file system and is formatted with ext3. It's read-write, it's got the access control list and user extended attributes as mount options. The other file systems are virtual file systems and don't actually make up part of the file system. If we have a look inside the fs tab file, this controls which files systems are mounted by the system automatically. You can see we've got a swap file system, SDA2, which is my root file system, which is formatted with ext3. Again, we see various mount options. And the swap file system is a file system for the virtual memory. We don't access it as a file system itself. And of course the other virtual file systems for proc and dev are listed there as well. If I use the command fdisk-l, we can then see I've got two physical disks in this machine, SDA and SDB. I don't have a partition table for SDB, but again I can see then my two physical partitions that we saw in the fs tab file, SDA1 and SDA2. If I want to create more partitions, they need to be formatted to be accessed, and we can format them with a range of file systems. We can see the default here was ext3, but there are a range of file systems that can be used. If I just go into the graphical utilities to demonstrate this, and if I go through and create a new partition, so as I move around to my hard disk and to SDA and then add, we say new primary, we set it to a certain size, so I might just say another gig, and then we can choose to format it, so make it available, and we can see there are a range of file system options that appear here. So we need to understand a little bit about some of these file systems. Let's say the default is ext3. Now we don't need to use a graphical tool. I think sometimes it's easier to understand what's going on when we look at it from the command line. So if I now go through into fdisk, you might have used this years ago with DOS and your early versions of Windows. So I'm going to fdisk dev SDA, I'm going to create first of all an extended partition, so I choose new for a new partition and then E for extended. I can create well, not as many, but virtually as many logical partitions as I want in an extended partition. So I'm just setting up then the extended partition to use the rest of the disk. Now I'm creating a new partition again, and this time I'm going to say a logical partition, so this will be SDA5 inside my extended partition. Again, I'm going to set it up to be a gig. Print out with the P so we can see what partitions I have now. So SDA3 is my extended, SDA5 is my newly created then Linux partition. I'm going to create another partition now. So this will be SDA6, again another 1 gig partition. We print that out so we see SDA5 and SDA6. SDA4 is skipped because we reserve those for primary partitions, not for logical partitions. So I write the file system and then I use part probe to make sure that my MBR, my master boot record partition table, is synced with the memory resident partition table. The graphical tools would all do this for me automatically, but we don't then get the understanding of what's happening. So if I have a look at my dev structure for then SDA and question mark, so this will then show me SDA1, SDA2, SDA3, SDA5 and SDA6. 5 and 6 being my new partitions. Now partitions themselves are not file systems, so I can't mount them until they've been formatted. If I run muckfs dot and then tab, we can see there are a range of file system formats that I can use on this server, more than we could actually see in the graphical environment. The default, as I say, is ext3, so I'm going to format SDA5 as an ext3 file system. So this is a journaling file system, so it has a transaction log of which files are being changed. So it's quite efficient from that point of view, but essentially is an older ext2 file system with the journal thrown on top. There is a later ext2 file system, but it's still not enterprise ready as far as SUSE are concerned, and it's not the default file system in SLES 11 currently. So now I can mount the file system. Mounting the file system is a little bit like assigning a drive letter to it. So if I mount it, let's say, to the mount directory, I can access this file system through the directory /mnt. If I check the mount command by itself and just look for then the mount directory, we can see that SDA5 is mounted as an ext3 file system and with the option read write. If I remount it, so mount -o remount, comma, read only, no spaces there, mount, and then go back and search again, we can see now it's mounted as read only. Read only means, well, I can't write to it even as root, so if I try and create it, I can't. This might be because it's just an archive directory, they don't need to be changed, or perhaps I need to protect the file system because the system might have crashed and I want to just turn it off. Often though, these are used for archive file system where we don't want files to be changed. If I remount it as read write, I can add other options, let's say like access control list. Access control list extends the permissions of a file and allows multiple users and groups to have permissions. Now we can see that the mount directory is available with read write and ACL mount options. Now you can see as well, running the touch command, I'm of course able to write to the file system and now create file 1. So ext3 is a generic everyday file system that works reasonably well. We'd need to put an entry into this into our FS tab file should we want to make this available every time the system started. We probably wouldn't mount it to the mount directory, but we'd create a directory called, I don't know, data or whatever. If I run the dump e2fs command, This allows me to see information, to analyze information about the file system. So if I go through and then run that on dev SDA5, we can see when it was created, its UUID, its unique identifier, the block size, how many inodes we have in the file system, and then we can look at all of the information that relates to the file system. So it gets quite technical. If we leave eXD3 behind for the moment and look at an often overlooked file system, XFS from Silicon Graphics. This was first written in 1994, so it is a very mature but is a high performance 64-bit file system. So if I now format SDA6 with XFS, we get the metadata coming back. It formats very quickly. All the information is stored in the metadata. We don't actually write through to the disk until we need to create our files. If I unmount mount for the moment, and then we'll remount it, so run the command mount, and this time it's going to be SDA6 that is mounted. And of course, if I go through now and have a look at the mount options for this, we should see that it's read-write and the XFS file system. So the XFS file system was designed, as I say, by Silicon Graphics. It's designed for high performance access to your files. It will work with both small files and large files, but was predominantly written for large 3D modeling systems. I can get my information, the same information I saw, and we can see it's actually summarized far better than the dump2 EFS. We also have some fairly nifty commands that we can use that other file systems don't have. So if I use XFS _ DB, so I want to diagnose a file system, I'm going to use the command frag and make sure that it doesn't write, so it's only a read-only operation, to dev SDA6, and we can see that it's not fragmented at all. I've only got one empty file, so you wouldn't expect it to be fragmented. But Linux file systems can become fragmented, and of course it's quite useful then if a defrag command is included, so I can analyze with the db command, and then XFS _ FSR allows me then to defrag the file system. Another useful tool is the freeze command. So I can freeze the mount directory. It's still shown as read-write, but if I try and edit, you see I'm using Vi and my system has kind of just frozen. If I move across to another terminal and then unfreeze the file system, then of course Vi continues to work. This freezing is really pausing the file system, and is essentially very useful if we have to use it with like LVM snapshots for a moment in time. Then whilst the snapshot is being created, we can ensure no writes happen to the file system at all. So maybe XFS is a file system that you should be looking at, but hopefully this has introduced an idea of some of the file systems and how they are used in Linux. Thank you.